So hello everyone. Let us start the assignment of week 12. So let us go to the first question first. And this is a true false question. So let me write the question first. The question is, I am going to give you a signal and you have to say what is the minimal possible value of sampling frequency for that signal. So let me solve the question. See, what is the frequency here? It is cos 400 pi t. So 2 pi fct is equal to 400 pi t. And fc is equal to 200. Now, this implies that there are two del pulses, one at minus 200 and 200 Hertz. So the question said that the minimum possible value for sampling frequency of a signal of cos 400 pi t. So if we sample by 400, we can see that there is a 200 component, and if we sample it, this minus 200 will come at 200. So we can conclude that this is not possible to sample at something like 400. We should do it greater than 2 into FC, that is greater than 2 into 200. This should be greater than 400. So anything greater than 400, not 400. So the correct option is false. Next question. Next question is, sampling converts an analog time signal to a discrete time sequence. It's true. B is false.
The answer is true. Sampling converts an analog signal. Yes, right?
Yes. But
Yeah.
if it was said that it is digital instead of discrete, it would have been false. Like this is just only sampling in the time domain. Sampling converts it in a discrete time sequence, but after that we have to quantize that signals so that we can make it digital. So it is true for this sequence, like if we say discrete, but if the question was sampling converts an analog time signal to a digital time sequence, if that question was like that, then it would have been false. Okay, let us go to the next question. So if the number of bits in a PCM system increases from n to n plus 1, the signal to noise ratio will be changed by what factor? That is the question. So there are 4 options. First option is decreased by a factor of 4 to the power n. Option B, it remains constant. Option C is increased by a factor of 2 to the power n, and option D is none.
The option C, sir.
What is the answer?
2 to the plus 2 power.
Your voice is not audible. Can you type it in the chat box?
Okay.
It is increased by 2 to the power n. No, that is not right answer. Okay, so let me solve the question. So what is the number of quantization level L of n in the beginning? It was n number of bits was
2
used.
to the power of n initially. Now it will change to 2 to the power of n plus 1.
Yes. So basically, now if I want to get the ratio L of n plus n1 by L of n, what will it be? 2 to the power n1. Basically, this is the factor only extra due to this. So if we think about the quantization error ratio, that is del of plus n1 by del of n, it is equivalent to this ratio also. So that is half to the power n1, because we just sorry, let me write it. We have used the wrong notation. It is actually reverse of the situation. So this is the error for n bits. Now we know what is the quantization error Qn. That is del square n by 12. That is for uniform error. We thought of uniform error, and if we have calculated this is the error actually. So now we calculate this ratio, and this is what this del square term comes n plus 1 by, for Qn, only del square n. So only this factor will be squared, so 2 square n1, that is equal to 1 by 4 whole to the power n1. So we can say this ratio, that is the question, signal to noise ratio, how due to quantization process. So let me write it. So from here we can write that signal to quantization noise ratio will be changed by a factor of 4 to the power n, because it is the ratio of q of n plus n1 by q of n. So that is the ratio of the noise. So noise is getting decreased by a factor of 1 by 4. That implies that signal to constellation noise ratio will be changed reciprocally. So that is 4 to the power n here. So this is we can say it is either increased by a factor of 4 to the power n, or in the other word decrease, because we have only used the notation of decrease. So if we write decrease by a factor of 4 to the power minus n1. So none of the options matches here. It is 4 to the power m decreases, so decreases by a factor of 4 to the power minus m, not m. So this is not the option, this is not the option, this is not the option. Option D is the none, which is the right option. So is it clear to everybody, or I should repeat it once?
It is possible, sir.
Can you just write in the chat box, like your voice is not audible actually.
So, can I get the answer for question 1 again? The minimum possible value of sampling frequency for this should be the Nyquist rate, right?
So that should be greater than
yeah, so it's true. Answer is true.
It should be greater than 2 into 200. Like there is a impulse function at exactly 200. So if you sample at 400, that minus 200 will come to the 200 again. So there will be interference. So anything greater than 400, that is the answer. Not exactly 400.
Yeah, anything greater than 400 will be greater than the Nyquist rate. So the answer is false, is it?
Yes.
Okay, thank you.
Okay, you have asked to repeat. Okay, let me do it. So, and here it is clear, right, for you? Like, let me write it once for you. So this is quantization level is 2 to the power n, and for ln into n plus 1, it will be 2 to the power n plus n1. These many levels are there. So when you are thinking about the error, more the number of levels, lesser the error. That is the, that is only not proportional to, inversely proportional to error, number of levels, right? So we can write that L of n by L of n minus n plus n1 is somehow proportional to the error n1 by del of n. And now just check the ratio ln by ln plus 1, what it would be? This factor will be 1 by 2 to the power n1. So this will be also 1 by 2 to the power n1. So we got what is the ratio of del of n by n plus n1 by del of n from here, from the levels. How many levels we have used? N number of bits and n plus n1 number of levels we are using. So what is the error ratio between these two different quantizers? Now we know what is the Qn. So Qn is actually this error square, error variance by 12. So Qn also has a ratio between these two, n plus n1 by q of n. So that is proportional to the, what is the actual noise, that is del square n by n1 here, this is n1 by del square of n, because for this it is the noise and for this it is the noise power. It is the noise power for this and this is the noise power for this, from this noise power equation, and del is the actual quantization error. So from this we can write what this will be, as it is del square term, so just a square of this term 1 by 2 to the power n1. So this is 2n1, we can think of that. There, these two terms comes inside, it becomes 1 by 4n1. So it says the noise ratio is by a factor 1 by 4 to the power n1. So from this we can say that, because see here the noise is just decreasing by a factor of 1 by 4, right? Because this ratio is 1 by 4 in 1. Following this we can say that signal to quantization noise. So here is the signal power and here is the quantization power, right? So this noise is decreased by a factor of 1 by 4. So that will be reflected here. So the denominator decreases by a factor of 1 by 4. That means this signal to noise quantization noise ratio, that will be increased by a factor of 4 to the power n1, because the noise part, this is decreased. So the denominator decreases means the whole ratio will be increased by a factor of 4 to the power n1. Or you can say this decreases by a factor of 4 to the power minus n1, because we are saying it is decreases. So these two statements are correct, but see the option, it says decreases by a factor of 4 to the power n1. So it decreases by a factor of 4 to the power minus n1, not 4 to the power n1. So that is the reason option A is not correct, and option C is also not correct. So none of the option matches, that is the none. I think it is clear for you right now. Otherwise, if you have a particular question, okay, fine. Let us go to the question number 4. let xt is a sinc function 2 pi f1t, and yt is sinc square 2 pi f2t. So question is, what is the sampling rates xt and yt? Okay, so the first function is xt, and xt is a sinc function. So how can we write a sinc function? Sinc function definition, as we remember, is if sinc of t equal to sine t by t. So this is basically a sine wave normally. So we can write sine 2 pi f1 t by 2 pi f1 t. So the fundamental frequency is f1 here. That is the only catch. From that we can write the frequency of xt is f1. So the Nyquist frequency will be 2f1. But here you can notice that it is sinc square. So there will be a term comes sine square term of 2 pi f1t, and this is a nonlinear term. So basically this contains a 2f1 term. Like if we simplify this sine square, like there is a sine square of t term fct. So if we simplify in the term of cos 1 minus 2 cos square term, 1 minus cos 2 fct. So basically that frequency becomes from fc to 2fc. So for this Nyquist frequency will be 4fc. So the first one should be greater than 2f1, the second one is greater than 4f1. So let me write it for greater than 4f1, this is greater than 2f1. If anybody has any doubt, they can write in the chat box. Now again write xt is equal to sinc 2 pi f1t and yt is equal to sinc square 2 pi f1t. The same question, but now you have to calculate what is the Nyquist sampling rate for x of t plus y of t. Just put a twist here. This is f2t. So I am giving you the options. First one is f1 plus f2. Option B is f1 plus 2f2. Option C is maximum of 2f1, 4f2, and option D is minimum of 2f1 and 4f2. Okay, so the first one we already know has a Nyquist frequency of 2f1, and second one has a Nyquist frequency of 4f2. So when we add up two sequence xt and yt, it becomes x1 of f plus y1 of f due to linearity property of Fourier transform. So now this x1 has a highest component of 2f1 and this has a signal frequency of 4f2. So the total signal will have a maximum frequency, that is maximum between 2f1 and 4f2. Which of the following is maximum? That is the highest frequency in this x1f and y1f. Because this is 2f1 and this is 4f2, so depends on which one is greater. If 2f1 is greater than 4f2, then the highest frequency is 2f1. If 4f2 is greater than 2f1, then the highest frequency is 4f2. So we have to think what is the maximum bandwidth, and Nyquist frequency will be this, because the bandwidths are f1 and 2f2. So either 2f1 is the Nyquist bandwidth or 4f2 is the maximum Nyquist bandwidth, because the signal components that are present are f1 and 2f2, and these are the Nyquist. So either we have to do at 2f1 or 4f2, but if 2f1 is greater than 4f2 and we do at that case at 4f2, then this signal will not follow the Nyquist sampling criterion. Similarly, if 4f2 is greater than 2f1 and we just do at 2f1, at that moment again Nyquist criterion will not be valid for 4f2. So what is the maximum between 2f1 and 4f2? That we have to calculate, and after that we can say that what is the maximum of that. That is the highest Nyquist. That is the highest. Sorry, we should not write highest. That is the actual Nyquist sampling rate for x1t, xt and plus yt. This is the reason. Now the next question is, what will be the sampling frequency for x1t into y1t? And I'm changing one option to 2f1 to 4f2. So just try to calculate and comment it which of the following will be true.
Is it option A?
Yes. because just the frequency is f1 here, similarly to f2. So when we do x1t into y1t, this becomes x1t into y1t. This has a signal component, that is f1 plus 2f2. Another is f1 minus 2. So f1 plus 2f2 is the highest frequency. So the Nyquist bandwidth will be, Nyquist sampling rate will be twice of that, twice of f1 plus 2f2, that is 2f1 plus 4f2. So now just again I'm changing the on the operation here. This is the
So I have a question here.
what?
So I have a question. Yeah. Actually, this is supposed to be question 6. That is the multiplication of two signals.
Yes.
Question 5 is the addition. So
Yes.
the answer for addition, that is question 5, Nyquist rate should be 8f2, right?
No, that is addition.
No, because
right?
you are calculating Nyquist sampling rate.
Yes, for xt plus yt.
Yeah. Because it's asked, the question is Nyquist sampling rate. So first we are determining the maximum between 2f1 and 4.
No. See, the frequency is f1 and 2f2.
Yes.
So Nyquist frequency
Yes.
is 2f1 and 4f2.
Yeah. So 4f. So answer is C.
Maximum of 2f1 and 4f2.
Yeah. That is answer is C for question 5. Then.
Yes. If we take the addition operator.
Okay. Yeah. Okay. Okay. Fine. Thank you, sir. And for question 6, it is 2f1 plus 4f2.
Yes.
Okay.
Now if I put the operator as a convolution operator here, which one of these will be true?
It should be then same like addition again. So it should be option C then.
No.
No, sir. Then what is it?
Because what we are using x1 of t into y1 of t, right? So this is a convolution in time domain. So from the properties of the Fourier transform, we know this is a multiplication in the frequency domain. So I am giving you two frequencies here, like two representation. The visualization will be better. Suppose x1 of f is this, and y1 of f is this. So what will be x1 of f and y1 of f? The other terms are 0, only this part to this part will be multiplied. Suppose this comes like this and here it goes down. So this takes actually the bandwidth of x1f, right? Now similarly, just draw another thing. Suppose y1 of f is here, just like small, and x1 of f is the bigger one. So what will happen? x1 of f and y1 of f will take the bandwidth of this smaller one. If I take this and take this, suppose so it is going to take the bandwidth of y1 of f, bandwidth. Similarly, this is the bandwidth. So always x1 of f and y1 of f is going to take the smallest bandwidth. Which one have the smallest bandwidth? For here y1f has the smallest bandwidth than x1f, so the bandwidth of that multiplied signal is of y1f. Similarly, for when x1f is smaller, then x1f and y1f is going to take the bandwidth of x1f. So what is the operation? x1t convolution y1 of t. So we are going to take the convolution. So this is basically multiplication in the frequency domain. So now the question is, so first we just try to get what is the bandwidth of x1t into y1t. So bandwidth of x1t and y1t, like bandwidth will be minimum of f1 comma to f2. So from here we can say that will be minimum of 2f1 comma 4f2. That is the Nyquist. So option D is correct in this scenario. Like it will be minimum of 2f1 and 4f2. Is it clear for everybody? I think it's clear for everybody. Like anybody has any doubt, they can comment in the chat box. Okay. Now I am changing the question again. Now it is x alpha t, x to the power alpha t, and y1 to the power beta t. And this is a simple multiplication, not convolution. So here I am going to change the options. So which of the following will be true?
Is it option B or
Option?
option 2? Yeah, option 2.
Yeah, option 2 is the right answer. Like,
Because it is similar to the other one where we just had multiplication without powers. So here when powers are added,
and this
naturally,
yeah,
yeah,
this x1 to the power alpha, so whatever power I am going to get a signal,
yeah,
it just
yes,
gets the frequency that times of f1.
yes,
Similarly, this will be beta of f2, and there is a square term, so that will be 2 beta f2. So Nyquist will be 2 alpha 1 plus 4 beta f2. Hello. Okay. Now question number 9. It says a PCM system, pulse coded modulation, uses a uniform equalizer followed by 5-bit encoder. The bit rate of the system uh, so the maximum message bandwidth for which the system operates satisfactorily giving 4 options. First one is 250 megahertz, 500 megahertz, 750 megahertz, 1000 megahertz. any answer? Okay. So a uniform equalizer with a 5-bit encoder, and the bit rate of the system is 10 to the power 10 bits per second. So what should be the sampling rate? 10 to the power 10 bits per second it is coming, and it has a 5-bit encoder. So the sampling rate that should be, that is total number bits are coming per second is 10 to the power 10, and encoder has a 5-bit representation. So this is 5 bits per sample, and this is 10 to the power 10 bits per second. So this is 1000 mega samples per second. This is the sampling rate. So what should be the maximum message bandwidth?
Half of this.
Yes. So this should be 100 megahertz. Let us go to the last question. It says "Twen 24 voice signal are sampled uniformly, and what is the rate? Rate is 10 kilohertz. And we sent it the time division multiplexing scheme, like we are multiplexing in the time domain. So at particular time one user is getting the signal, and there are 24 voice signals. So at a particular instance we are sending one of the voice signals. So that is the TDM scheme. Like first we send the first, then we second, then third, and at every instance we are just particularly dedicating one voice signal. At a particular time one voice signal is going, and in this way 24 voice signals are going in 24 different instances. So the sampling process uses samples that are of one microsecond duration. And then one extra pulse of duration 1 microsecond is added for some synchronization purpose. So question is, what is the spacing between two consecutive pulses? So once again I am repeating the question. So we are using 24 voice signals at uniformly at a 10 kilohertz. Then we are sending it through a TDM scheme. So we are using a sampling process for sampling defined voice signals. So every signal is for a 1 microsecond duration, and this 24, and after sending these 24 voice signals, we are sending one extra pulse duration of 1 microsecond. So after sending 24 voice signal, we are just sending one more extra pulse that is of 1 microsecond for synchronization purpose. So what is the spacing between two consecutive pulses? The key fact you have to just remember that every sampling we are just trying to send some within one sampling interval, like we are sampling at 10 kilohertz, and within one sample interval we are just sending all the signals. Okay, so let me do this one. So how many voice signals are there? 24 voice signal, and then one extra pulse of duration 1 microsecond. So the total number of signals is 24 plus 1 extra pulse. So total 25 number of signal. Now the sampling interval is 1 by sampling frequency, that is 1 by 10 kilohertz, so that is 100 microsecond. So there are 25 signals that need to be sent in the sampling interval. So spacing between two signals should be 100 by 25, that is equal to 4 microsecond. Now the point that is given here, that the sampling process itself uses samples dated of 1 microsecond duration. So within this 4 microsecond, 1 microsecond is being used by this sampling process itself. So the remaining is 4 minus 1 microsecond. So that is 3 microsecond. So this is the spacing between two consecutive pulses. So once again I am repeating, we had 24 voice signals, then one extra pulse of duration 1 microsecond is going to be added, so that's why we have added it as 25 microsecond to total 25 signals. And then we have calculated what is the sampling interval due to our sampling frequency here, 10 kilohertz. So that comes 100 microsecond, that is the sampling interval. So within this sampling interval we have to send all these 25 signals. So each of the signal will be of 4 microsecond, and 1 microsecond is being used. 1 microsecond, this 1 microsecond is used by the sampling process. So 1 microsecond is getting deducted from this 4 microsecond, and this becomes 4 minus 1, that is 3 microsecond here. And this 3 microsecond is actually the difference between two consecutive pulses. So the spacing between two consecutive pulses is 3 microsecond. So anybody has any more doubt here in this question? Or all over the session, any question I have to repeat? Fine. So probably there will be one more extra session on this Monday or Tuesday probably. But for that you have to send me all the questions beforehand, not in that particular moment, because I have to solve this question once again. Like I need just a little bit time to just see the questions and solve those.
Extra session on Tuesday, sir?
Probably. Just, till
Okay.
like that they have announced, but probably you will get a mail.
Okay, and timing
It will be from 7 p.m. to
likely
9 p.m. probably.
7 to 9 p.m. Okay.
Probably. I'm not sure till now
Okay.
because they will send you a
Okay.
mail, I
Okay.
think.
Okay. Fine. Thank you.
Okay.